Alright guys, in the last video we looked at how to find the sequence of transformations, given your pre-image and your image equation. Today's video will be similar, but we'll be making use of a transformation using matrices. So T of x and y in brackets equals to A00b times xy plus CD. And the question would simply be asking you to find the values of A, B, C, and D. This is more typical to what you would see in the exams. Now essentially this is the same as finding the sequence of transformations. So the first thing you want to do is rearrange your pre-image and image equations such that everything to do with the y value is grouped on the left side. And so your pre-image would be y minus 3 over negative 2 equals to 5x plus 1 squared. And your image equation is y dash plus 6 over 2 equals to 10x dash plus 21 squared. Now, as I said before, they're trying to find out what the sequence of transformations is by simply finding out these values. And sometimes they won't give you these dashes, so make sure you include them. And now that we have the grouped equations, what we want to do is compare the x expressions together such that we have x dash equal to half x minus 2, and compare the y expressions together so that we can get y dash equal to negative y minus 3. And this is by no means all the steps you're supposed to do. There are a few more steps involved along the way, but these are all the same things I've done in the previous video. So if you want to know how I've rearranged all these equations and then found these transformation equations at the end, please have a look at my previous video on finding the sequence of transformations. So once we have the transformation equations down here, we want to move on to the matrices. Firstly, we need to simplify this expression on the right hand side down to a single matrix. And so A is going to multiply x, 0 will multiply y, so that's just 0, and then 0 times x is also 0, b multiplies y to give you by. That will add c and d, and so we end up with ax plus c and by plus d. At the same time, we can also replace this expression on the left-hand side by rewriting it as x dash and y dash. So when you compare the left-hand side with the right-hand side, we can extract two equations, x dash equal to ax plus c and y dash equal to by plus d. These equations look very similar to what we found before. So it's really just a matter of comparing these terms together to see what the values would be for a, b, c, and d. For example, when you compare the x terms together, we can see that a should equal to half, and c must be that constant next to it, and so c is negative 2. We can do something similar with the y terms, and so b is negative 1, while d is negative 3. And that's our answer. If you guys are struggling to compare the expressions together, then feel free to write them side by side or above each other like this, x dash equal to ax plus c and x dash equal to half x minus 2, and that might make the job easier for you guys. Now there is an alternative way to how this question can be worded in your exams based on this matrix here, because what we have at the moment is a DR matrix, so a dilation and reflection matrix, followed by a translation matrix that is being applied to your pre-image variables and your pre-image equation. This won't always be the case. Sometimes they will swap it around. So let's have a look at that now. So here's another possible arrangement they can give you for your transformation matrix. If you have T of xy, this is going to equal to A00b. So far it's the same thing, but this is going to multiply x and y, adding c and d inside a bracket first, which means your translations are happening first, followed by your dilations and reflections. And I will say that this version of the question is a little bit more difficult and a bit more tedious than the other one, and you'll see why in a second. There's two areas where it's going to be more difficult. The first is simplifying this matrix. So we can't do anything with this matrix outside here. What we need to do is figure out this bit inside here. It's simply just x plus c and y plus d, but these are single elements in a single column. And so a is going to multiply x plus c, giving us ax plus ac. It's like a factor expansion. 0 will multiply y plus d, so that's just nothing there. You can say plus 0, but there's really not much point to saying all that here. And on the second row, 0 is going to multiply x plus c, which is still 0. so you don't need to write anything there. And that will add b times y plus d. So that's by plus bd. And on the left side, you can just write it out as your x dash and y dash matrix, which can now be compared as two equations. X dash will equal to ax plus ac, while y dash equals to by plus bd. So some students might struggle with the calculations here. Another area of struggle might be comparing these equations to these equations. They're a bit different from before because now you have ac and bd instead of just a single value. So first things first, we know that a will be compared with the half, and so a is simply just half, while b is compared with the negative y, and so b is negative 1. From here we need to apply some algebra to figure out c and d. ac is equal to negative 2. We know a is half, and so that's going to be half c equal negative 2 times both sides by 2, and c equals to negative 4. We've got the answer. Do something similar with b and d. So b d equals to negative 3. b is negative 1, so that's negative 1d equal to negative 3, or just negative d, times both sides by negative 1, and d is positive 3. And those are all your answers. This may not be the best example for what you might get in the exams, because usually I notice these equations tend to be more complicated in the exams, but I hope this was simple enough for you guys to understand and learn something from it. Let me know what you guys think down in the comments below, and if you like this video, hit that like button and share it with your classmates if you think it'll help them too. And don't forget to subscribe and ring the bell by clicking the buttons down below. Thanks so much for watching, guys. Have a good one, and I'll see you next time.